I'm going to explain how to solve a rational inequality. The first step is to get a polynomial over a polynomial, and then your inequality sign, whatever it is, and then a 0 on one side. So let's take the example 3 over x minus 5 minus 4 over x plus 3 is less than or equal to 0. So I've got the 0 on one side. I just don't have one fraction. So I'm going to get a common denominator. I'm missing the x plus 3 from the first fraction, so I'll put it in the numerator and denominator because x plus 3 over x plus 3 is 1, and multiplying that fraction by 1 won't change it. The second fraction needs x minus 5 to get that common denominator, so I'll put that in the numerator and denominator. And now I have an inequality less than or equal to 0. I need one fraction, so I'm going to write this over my common denominator, x minus 5 times x plus 3. In the numerator, I'm going to distribute and simplify, so I have 3x plus 9. Be careful of this minus sign, so I'm going to distribute really a negative 4. So I get minus 4x plus 20. In the numerator, I then get negative x plus 29, denominator x minus 5 times x plus 3 is less than or equal to 0. I now find my critical values. The critical values are what make the numerator or denominator equal to 0. So in the numerator, you might see what the answer is. If you don't, just set it equal to 0 and solve. And I get positive 29. The denominator, it's a little easier to see. A positive 5 will give me 0, and a positive 3 will give me 0, or a negative 3 will give me 0. I now make a number line chart comparing low to high. So negative 3, 5, and 29. When I make my number line, I usually tell myself what can't be 0. We never want a 0 in the denominator, so no matter what our answer comes out to be, we don't want to use positive 5 or negative 3. So I just put a little mark on my number line to remind myself of that. This shows me the intervals I'm going to test. So I'm going to test from negative infinity to negative 3, negative 3 to 5, 5 to 29, and 29 to infinity. So now I make my sign chart using those intervals. Negative infinity to negative 3, and I'm not allowed to use negative 3. Negative 3 to 5, and I'm not allowed to use either of those, so I'll have open intervals. 5 to 29. 29 would work in my problem because it could be equal to 0. So I'm going to put a closed bracket on 29. My last is 29 to infinity, so I'm going to put a closed bracket on 29 to infinity. I now think of a number in these intervals. So my test number for the first will be negative 4. My test number in here, I can use 0. 0 is pretty easy to plug in. 5 to 29, I'm going to use 6. And 29 to infinity, I will use 30. I'm now going to put them in my factored form of my inequality. So I'm really looking at negative x plus 29 over x minus 5 and x plus 3. I don't really care what the exact answer is. I just care whether it's positive or negative. So I get a negative negative 4 plus 29. That'll be positive. Negative 4 minus 5 is a negative. Negative 4 plus 3 is a negative. And a positive over a negative times negative is a positive. So I get a positive answer here. I now look at the original problem, and it says has to be less than or equal to 0. And a positive is not less than or equal to 0, so that's a no area. I now test 0. On the opposite of 0 plus 29 will give me a positive. 0 minus 5 is a negative. 0 plus 3 is a positive. I get a negative in the denominator. Positive divided by negative is a negative. Is that less than or equal to 0? Yes. Test 6. Negative 6 plus 29 is a positive. Negative 6 minus 5 is a positive. 6 plus 3 is a positive. Positive divided by a positive is a positive. Is that less than or equal to 0? No. Last number, 30, so negative 30 plus 29 is a negative. 30 minus 5 is a positive. 30 plus 3 is a positive. A negative divided by a positive is a negative, and that's a yes area. So now I'm ready to write my final answer. I just look over at my interval, and x can be any number between negative 3 and 5, not including negative 3 and 5, or x can be any number equal to 29 or higher. And that's my interval notation.